So hi all. So next we'll see about the brightness range adaptation and discrimination. So what is meant by a brightness range adaptation of a human eye? So it is nothing but it's a phenomena which describes the ability of the human eye in simultaneously discriminating the distinct intensity level. So like when we are seeing like a different, like for example we'll be sleeping for a long, like we'll be sleeping and like with the lights off, and suddenly when the light is on, so our eyes will take some time to be in that particular intensity, so we'll be feeling some irritation in the eye. So that is the brightness adaptation. Okay, so the brightness adaptation of the human eye is a phenomenon which describes the ability of the human eye in simultaneously discriminating the distinct intensity levels. Set to two different intensity levels, how it will be discriminating the particular intensity levels. So that is called a brightness adaptation of the human eye. So the brightness adaptation level is the current sensitivity level of the human system for any given set of conditions. So what is meant by next is a simultaneous contrast. It is a phenomenon which describes that the perceived brightness of a region in an image is not a simple function of its intensity. Rather, it depends upon the intensity of the neighboring regions. So whatever the intensity that is perceived by a human eye, it is not only depending upon the particular object. For example, we are capturing a person image in a camera. So the intensity, the perseverance of that particular intensity of the human eye, that does not depends upon the particular person. It also depends upon the background in which the person is standing. So that is called what? The simultaneous contrast. So we'll see the brightness adaptation in detail. So the ability of the human eye to discriminate between brightness level is an important consideration in creating and presenting an image. So the range of light intensity level in which a human visual system can adapt is in the order of 10 to the power 10. So we are having, the human eye is having a very huge order in which it can adapt the brightness intensity. So that is from the scotopic threshold to the glare limit. So before going to this brightness adaptation, we'll see what is meant by the subjective brightness. So subjective brightness is nothing but it is a brightness as perceived by the human visual system. So that will be in the order of a logarithmic function of the intensity that is incident on the eye. So we can see this in this figure clearly. So you can see here. So you're having the log of intensity will be there. So this is the subjective brightness. So the subjective brightness, it will be ranging from the scotopic threshold to the glare limit. So that is in the range of 10 to the power 10. So that is nothing but your eyes will be having the photopic vision and the scotopic vision. The photopic vision is the bright light vision. That's nothing but used to the cones, and the scotopic vision is the dim light vision that is due to the rods. So this photopic vision, that is a bright light vision of the human eye, it will be ranging from the scotopic threshold to the glare limit. So the subjective brightness, so we know that the subjective brightness, it is nothing but the logarithm of the intensity that is falling on the eye. So for example, so like what is meant by brightness adaptation? So that is given by this thing BA. Okay, so this short line, that is BA. So nothing like, even though the eye is having the very high range for the subjective brightness, so the range at which the human eye can distinguish between the two different intensity. Okay, so that phenomena is called what? The brightness adaptation. Okay, so even though your eye is having the high range of brightness adaptation range, but the range or the human eye will be like, it will be very difficult for the human eye to distinguish between two different types of intensity. So that phenomena is called what? The brightness adaptation. So that is given by this range BA, and below that you're having a range called the BB. So that is below this, so it will be full of the dark region, and above the BA, you'll be having the full of the bright region, or it will be in the visible region. So that's all about this graph, the brightness adaptation of the human eye. So in this, you can see that the long curve represents the range of intensity to which the light, which the visual system can adapt. So it is in the power of 10 to the power 6. And the transition from scotopic to photopic, it is in the gradual. So that is from the dim light to the bright light vision. So that is a gradual transition will be there. So that is illustrated by these two figures, that is scotopic vision and the photopic vision. So the brightness adaptation can be explained with the help of matched bands and the simultaneous contrast and optical illusion. So what is meant by the matched bands? Okay, so the matched bands are the adjacents. You can see in this figure, it is of constant intensities of squares. So that will be like it will be the constant intensities of the rectangular strips will be arranged in a simultaneous manner. So in this you can see that, so here you could see here the, even though it is of constant intensities, but here you could see that the left hand boundaries are bright and the right hand boundaries are dark. So you could feel that. So the left hand boundaries, that means the left hand boundaries are brighter and the right hand boundaries are getting dark. So this is the perseverance you could see while seeing this. So that is called the matched band effect. So here you can see that in this figure, this is the matched band. This is the original actual intensities, and this is the perceived intensities you could be seeing after seeing this matched bands. So the visual system tends to undershoot or overshoot around the boundary of the region of different intensities. That is the perseverance what you are seeing, and this is the perseverance of the intensity level that you are seeing, and this is the actual intensity that is already existing in this particular matched band. So that's the same figure it is showing here. So the luminance, so the dark steps, so that will show the actual intensities, and the perceived lightness will be of some small changes when compared to the actual intensities. So that is the matched band effect. And simultaneous contrast. So next is simultaneous contrast. So in this you can see that each like you can see here, so that each small squares will be there. So each squares of same constant intensities will be there, but you could feel that the squares will be of the small squares will be, I'm telling, so small squares will be of brighter or lighter intensities due to the background in which it is there, right? So here you could see that it will be there in the black or the dark background, and you could see the intensity of the smaller square could be very less. And this here it will be in the white background, the intensity you could see it's more brighter. But even though, both the small squares are of same intensity. So that is a simultaneous contrast. Here also it is showing the same thing with the gray background and the lighter dark background. So next is the optical illusion. This is also the brightness discrimination of the human eye. So you could see that here a small square will be, even though the small square is not there, you could see a square in between this all four circles. And here the same here you could see there many lines will be arranged in a circular manner. You could be able to see a small circle over this. And next you could see that these two lines will be there. So these two lines you could feel that the second line will be more larger when compared to the first line. So it's nothing but the perseverance of your eye. Even though the reality is it's not same, but the perseverance you could feel it's same. And here also you could see that the actually lines are arranged in a parallel manner because of this random strips. You could see that it is not parallel to each other. So that is the optical illusion. So next topic we'll be covering is about the brightness discrimination. Okay, it is the brightness discrimination. Okay, so the brightness discrimination, for example, I'm taking, okay, so an opaque glass I'm taking. Okay, I'm taking an opaque glass. Okay, so this is an opaque glass. So I am going to flash a light on this opaque glass. So what will happen? So the light intensity that is falling on the opaque glass will be what of equal intensity. So that is given by I. And also in the middle of this glass, okay, in this middle of this glass, I am giving and flashing another intensity of light of short duration, that is delta I. Okay, so now you could see that, so in this small duration of light that fall will be I plus that total intensity of I plus the delta I, right? So that is nothing but you can call that is the brightness discrimination. So here you can call it as the delta I by the whole intensity I. So this is called the Weber ratio. So this is called the Weber ratio. So we could see that if the Weber ratio is more, the brightness discrimination is very poor. Okay, so that is called the brightness discrimination. Okay, so I hope you understood what is meant by the brightness adaptation and the simultaneous contrast and the brightness discrimination. Okay, so that's all for this topic.